Hi there, guys. This is just me, Mr. Wee. I'm just gonna help you guys out with like a chapter that we didn't really get to go over in class. So if you remember, we were going over 2-6, analyzing functions with successive differences, and we're looking at three different types of functions. So we're looking at a linear function. This is basically just a general line. This is the general equation for it: y equals mx plus b. A quadratic, which you know as this U shape, is called a parabola. Okay, um, and it has this general formula: y is equal to ax squared plus bx plus c. The a, the b, and the c are just kind of like constant numbers, like a 5, 3, 4, 7, some kind of number attached to the x value. And as long as there's an x squared in the equation, you're going to have a parabola. And this is what we call an exponential curve that almost looks like a linear function, only the slope between 2 points always changes as you go further and further along the x-axis. Okay. Now we want to identify these three functions just by looking at data tables. So I believe this is where we left off last time in class. I gave you a data table. So let's see if you look at it here. I gave you a data table with just these two numbers, a bunch of x values and a bunch of y values, okay? And then I asked you to determine if this was a linear function, a quadratic function, or an exponential function. And all you had to do actually was just find out or just kind of realize that we're kind of going up or down a certain value as we go to the right on the data table. So as you're going to the right, your x value is going up by 1. Okay, so that's not really significant because your data table should hopefully go up by the same kind of number increment. What is of note is that as you're doing that with the x values, the y values are actually going up by a similar amount. If that's the case, we deem that as a linear function because we say that the first differences, you'll see why we're calling it first differences, are the same. As in, it's just plus 5 every time. You can sort of look at that as sort of like a change in the y over the change in x. That'd be like plus 5 divided by 1, like your slope. So remember, it's like a y2 minus y1 over x2 minus x1. So if you think about it, it'd be positive 5 divided by positive 1, and then you get a slope of 5. And if you do that again with the next one, you can do the change in y over the change in x. You don't have to do this part. I'm just kind of showing you some extra stuff to kind of understand. You'd still get the same thing. 5 divided by 1, that's still 5. And you keep doing it to every other kind of between 2 points, trying to find the slope. You're going to see that it's always positive 5 in this case, and that makes it a linear function. Anything with a constant slope, in this case, like between every 2 points is this still the same slope, you can see that this is a linear function. Okay? Now let's go through another example where maybe that might not be the case. So let me draw another value here, xy. So you can take this down as notes. -3, comma -3, -2, comma -7. So you can kind of follow along and put this in your notes as well. -1, -9, 0, 9, and then 1, -7. I mean, this keeps going on and on forever, but we just took a few points here. Now we're looking at it, okay? So let's see. Is this a linear function, an exponential function, or quadratic? Okay. So let's try the first differences test really quick. Now I notice from here, from every x value, I'm just going up by 1. So I don't need to do this test to the top. Okay, as long as it's going up by 1 up here or going up by the same amount, we're good. We don't have to do anything else to the x. Here, though, the y values are always the guys that I'm kind of paying attention to. So from -3 to -7, what you actually did was you subtracted 4. And then from -7 to -9, I actually subtracted 2. From -9 to, oh, I'm sorry, and that's a -9. I'm sorry. So these are both supposed to be -9. That's just 0. And then from -9 to -7, I actually added 2. Okay. Or did I? Let's see. Did I add 2? Yes, I added 2. So does this pass the first? This is the first differences test right here. First differences. Why is it called first differences? You'll see why in this example. Do they have the same gaps? Like, are they going up by the same amount? No. In fact, we had to subtract 4 here from these two numbers. Then we had to subtract 2 here. Then we didn't go up by anything. So these are not the same. So this is not a linear function. So we're going to just put like an X, like it fails this test. And we're just going to kind of put in parentheses, not linear. You don't have to write this part in, but I'm just saying this is not linear. Okay. But if you notice, if I took the differences between the first set of differences from -4 to -2, I added 2. From -2 to 0, I had to add 2. And then from 0 to 2, I had to add 2. And this is what we call this. So this line is the first set of differences. This line is the second differences. This test, and if it passes this test, okay, then you have a quadratic. This is a quadratic function. If it does not pass the first differences test, but it passes the second differences test, you are actually looking at a U-shape. Okay? So that's it. This is a quadratic, not a linear, not an exponential, but a quadratic. Okay? Okay. So again, the first differences, they're not the same. They're not the same. Second differences are the same number. If that's the case, it's a quadratic. Okay? So you're looking for similarities. One more example. One more example that we're going to go through is, let's say, we're going to kind of go through another table. So you can copy this down if you want. -1, 1 is going to be a point. 0, 3. 1, 9. 2, 27. 3, 81. Hopefully your mathematical intuition is setting off. This doesn't look like a linear, but it's something's going on because I can kind of tell from 1 to 3 to 9 to 27. There's something going on with the number 3 here, okay? Like there's like something kind of weird, all right? So let's just try the first differences test. From 1 to 2, or 1 to 3, I had to add 2. From 3 to 9, I had to add 6. From 9 to 27, I had to add 18. And then from 27 to 81, I actually had to add 54. Does this pass the first differences test? No. So you don't have to write this down, but it actually makes it very easy and very clear to understand. First differences? No. This does not pass. This does not pass the first differences test. How about the second differences? You had to add 4. Then you had to add 12 to get from 6 to 18. And then you had to add, let's say, 54 minus 18. I don't know if I could do that in my head. I believe that's 26 or 36, I believe. Okay, regardless, that doesn't quite work either. So the second difference is, so now we know that this isn't a quadratic either. The second differences test does not pass, okay? But let's try something else. All right. How about if we look at maybe instead of just subtracting or adding, we can kind of see if like maybe there's some kind of division or something going on. So what I'm going to do is this. I'm going to kind of say like these tests didn't work. And I'm going to rewrite this. You don't have to actually rewrite this when you're doing the work. But I just want to make it very clear in the notes what's going on. Okay. What I'm going to do now is I'm going to divide these two. So this is a completely different test. So I'm going to divide this number and this number. 3 divided by 1, that gives me 3. And how about this? Is 9 divided by 3 going to give me the same number? Uh-oh. Yeah, I took 9 divided by 3. So for this number, the number to the right divided by the number right next to it, 3. That's 3. How about 27 divided by 9? Like from 9 to 27. Yes, this kind of gives me the same number. And then this, 81 divided by 27, that is also 3. That is not a coincidence, and I'm not using addition and subtraction, but they are going up by the same rate. It's just we're not dealing with addition or subtraction. We're dealing with the fact that they're going up by a number that you or a rate, like as in like you had to take two numbers and you divided them or multiply them. That's huge. This should tell you that this is an exponential. This is no longer the first or second difference. This is just a completely different test where you're looking at ratios. So if you had to call anything, these are called ratios. So this test is called ratios, and then it passed, and then it makes this function exponential. Okay? If you don't believe me, graph these on your graphing calculator. I'd like to show you what this looks like, but I myself forgot how to do this into a data table. But let me see if I can grab that on my TI-83. All right, I can show you how to do that. All right, we'll start. We'll do that in part 2 of this video. Okay, but for now, this would be part 1 to help you out. So part 2, we're gonna actually plug this into the calculator and check. But this is how you do it on paper. Okay. All right, guys. You guys have a great day. Take care. Hopefully this helps you out. Bye.